Today I am discussing with you 3D plots. You might have seen 3D plots in many research papers. 3D plots are very useful. So in this tutorial I will tell you in depth about these 3D plots. 3D plots have their own important role in plotting and functions that cannot be interpreted with using 2D plots. There we use 3D plots. So MATLAB have many 3D plotting options, out of which these 5-6 are important. Number one, to plot using the basic plot command, that is called plot3. Instead of plot, you have to write plot3 command for plotting 3D plots. And here you can give some specification for x, y, z. Second command that is used for plotting 3D plot is called mesh plot, for plotting mesh surfaces. And third command is used surf command for plotting on the surfaces. And fourth command that is used for the 3D plotting, that is the ribbon. And fifth command that is used for plotting 3D is contour, for contour plots. And sixth one that is used for plotting 3D is slice. And seventh kind of a 3D plot is called sphere. And eighth 3D plot is cylinder. We'll go through these commands one by one. Okay. So first is plot 3. The plot 3, the syntax for plot 3 is either you can use plot 3 x value, y value and z value. 3 values are required for plot 3 command, like that. Our second way of writing plot 3 is plot 3 x, y, z, comma. You have to give some specifications, that line type and specs you can give with in addition to these 3 things. Okay, so we will learn these things one by one. First of all, we will try to create a simple plot by using the mesh grid command. So before plotting, we need to create values of x and y. So to create, you already know how to create an array of x. Array can be created like this: 1, 1, 2, 10. And array of y can be created as 1, 1, 2, 10. If you want to start from -10, then you have to write here -10, starting from -10 colon up to 10. Like that, we can create value of x and y. But this will be a linear array of x. This will be an array of y. But as here we are plotting in 3D, therefore we need a grid, mesh grid of x and y. So to create mesh grid, the command, another command is used instead of this. What we need a complete mesh like this. So values of x and y simultaneously. We need mesh grid. So this is called mesh grid. Okay. So for mesh grid, we use mesh grid command. Mesh grid command will create the value of x and y. If I write mesh grid from -10 colon 1 colon 10, this will create an matrix actually, which will be having the values of x and y. Let us try. X comma y equal to mass grid of starting from -10 with the increment of 1 going up to 10. Okay, so this I have created here. Both x is also a matrix and y is also a matrix. What command I have used? Mass grid. This command I have used, mass grid 10 to 1. This have created a mass of in the x and a mass in y. So the value z can be calculated with respect to these matrices. Instead of vectors, we use matrices of x and y to calculate the value here in the 3D plotting. This is important. So all of you should know that before going to 3D plotting, we have to create a mass grid. Okay, so or we have to calculate the values of x and y in 3 dimensions. So then only you will be able to plot. So this is how we can do. So then I will go to the command. So we have the command. This is one way to do. We can use the command. Which command? Now xy we have to calculate the value of z. Okay, so z, if z is, suppose I want to plot what I want to plot. Let me just tell you that I want to plot an equation that t equal to root over x square plus y square, where z is equal to tan sine of t. So what are the variables here? X, y and z. X and y are dependent variable and z is independent variable. What is the t? So t is actually an intermediate variable between x, y and z. Okay, so let us do this. Let us do this. Let us try to calculate the value. So t will be equal to sqrt of x dot power of 2 plus y dot power of 2, because here we are doing array multiplication instead of matrix multiplication. So this is equal to x square root of x square plus y square. Okay, so actually this is the, I'm mapping this equation here. You can see t is equal to square root of x square plus y square. Okay, we have seen this. Now I have to calculate value of z. So z equal to n sine z equal to, and now z is also calculated as per the equation we have given. Now we have value of x and y and z in the form of a mesh. So if I use the command plot 3 x comma y comma z. Sorry, there was some error. Okay, this was the error. You can see this is actually a line plot. This is a line plot. This plot is a line plot. Okay, so and this is plotted in 3 dimensions. So here you can see this as an x here, y here, z here, and this is the plot of z. The value of z is here in the z axis. This way we can do plotting. Okay, using the plot 3 command. Second kind of plotting option that I have discussed is called plotting with the help of mass command. By plotting with the help of mass command, let us try that. So instead of plot 3, instead of giving a plot 3 xyz, I have to use mass here, mess mass command, and then x comma y comma z. You can see this is better than the previous one. This graph which is available now, it is better than the previous one. So we can say that for this particular problem, mass command is better than the previous one. This plot 3 command, because here it looks better. Or if this is I will see, let us see the history and make it an script file. So I'm just going to see the history of this. Okay. This time opening the history, command history. No. This is the history, and just I am taking this command, this command, this command, this command, this command, this command, and click right click over here and create a script. So this is, script is created, and when I execute this, my first plot, I will save it here. Okay. So here there is this one is having error, and okay. And before starting any program, I usually write CLC to clear the screen and clear all previous variables, and close all windows that are already open. Here I am seeing that the mass is very thick type of mass, so I will just reduce the size of step size in this mass grid command to make the mass better. It's smaller mass, and further I will take a new figure window so that both of the figures can be clearly seen. Both of the difference between the plot 3 command and the mass command can be seen here. This one is figure 1 is plot 3 command. Okay, and first of all we have used plot 3, and then figure 2 is using the mass command. So plot 3 is giving the figure like this, and mass is giving figure like this. Okay, you can see clearly that mass is better than the plot 3 command. Now we have gone through the two different commands. Now third command is called surf command, which is called surface plot. So here the command is surf command, so command name is also surf. So I will take new figure window and write surf x comma y comma z, and execute this by going to the editor, run. There is a spelling mistake here. Okay, so this is the surface plot, and this is the mass plot, and this is using plot 3 command. So whatever plot you need, you can use that kind of plot for your purpose. Generating value of x and y is important. So there are different ways to generate the values of x and y. So one more way of instead of mass grid, you can use another command that is called peaks command for generating the value of x and y. For example, I will take another example for this surf command for plotting the equation z equal to e to the power minus 0.9 x square plus 0.5 x minus y to the power whole square x square minus 0.5 x minus y whole square. Okay, so we need to plot this function. Just we have to it's simple. What we have to do, we have to first of all we have to calculate x and y. So there is another way of creating a value for x and y is by using the peaks command, and this will generate 30 values of peaks. What this will generate matrix for x and y. Now I will calculate the value of z equal to exp e to the power minus 0.9 into x to the power 2 plus 0.5 into x minus y to the power 2. This way we are creating value of calculating the value of z. Now I have to write command surface x y z. Okay, you can have a color bar if you want. You can see here this is the for peaks. Okay, so this is a surface plot for this equation. Similar to the normal plot, you can give the x label and y label. Suppose you want to give x label to this, then you can write x-axis like this. Suppose you x-axis and y-axis like this. You can give these values. Okay, and if you want this to be this is a surface plot. This is another way of plotting surface plot. And third kind of or fourth kind of plot. So we have covered till now plot 3 command. After that mass command, and number 3 surf command, and fourth one is ribbon plot. So we can apply ribbon also to the same data. I will take an example of z equal to x square minus y square. Plot this as a ribbon plot. So what we have to do, let me take one command. So here also I will write clc clear. I can apply the previous one also, and I can take a new one. Okay, so xy we create by peaks. Okay, 30 cross 30 peaks. then z is equal to x square plus y. Okay, this is actually x square minus y square. I have to take. It's okay. Okay, so here I can use one small bracket. So here also for x square also I have to put a bracket, and this is the bracket closed, and this bracket. Value of z is calculated. I can say given x comma y comma z. So I say my given. I have done some mistake, therefore actually given it can be used only for that. So I will take only that. Okay, so this is ribbon plot. Here there are many ribbons that are being shown. This is in the ribbon form. Graph comes in the ribbon form. Okay, so this is called a ribbon plot. Okay, if I want to remove the axis from the plot, then I can say I can write axis of in the graph itself. So then axis will not be shown, because 3D plots many times looks very nice when there is no axis. Okay, so this is called ribbon plot. Now how many I have covered? We'll say I have covered number 1 plot command, number 2 mass command, number 3 self command, and number 4 ribbon. This ribbon command. Okay, these many things I have covered. So next is to have number 5 called contour plot. Okay, so contour plot can be plotted in for the same thing, the same kind of. Suppose I want to plot for the same this ribbon only. So here instead of ribbon, I have to write contour. For any three-dimensional function, this can be used, but the only thing is that you have to use contour instead of contour command for plotting contour plot. So this is the 5th number plotting function, that is contour plot. Okay, let me see how does it looks. Okay, so okay, this is contour. Okay, so this is the contour plot, but just you have to change the command. It will show contour instead of showing its other plots. If you change it to contour, then it will show contour command. Contour command you have to use for the plotting in the form of contour only. Okay, it was 2-dimensional contour that was shown to you. If you want to have a 3-dimensional contour, then you have to come up with the x, y, and z. All 3 values you have to give, and you have to write the command contour 3. You can see this is a 3-dimensional plot of contour. Okay. Next, the kind of 3D plot that is called slice plot. So slice x, y, z can give you this. Instead of writing the contour, we have to write slice. So by default it will take some slice. but in general we have to give values of slice also. For example, first one is of 0.1, second is of 0.5, and third value of slice is 0, like that. Okay, there is some problem. I'm using the wrong number of inputs, 1, 2, 3. Okay, and there is no fourth input should also be there. Actually, this takes 3-dimensional inputs or 4-dimensional, so x, y, z should be calculated beforehand. Plus z. I think it's okay, but okay, so the plot is little different than 3D plots types, and each coordinate or value mass grid should be x, y, z, and x, y, z, and we knew means you have to have a 4 different, I will say take it into a new. So here you have to calculate the mass grid first, x, y, z equal to mass grid minus 10 in the step of 0.1 to 10. This will create a mass grid from minus 10 to 10 in the step of 0.1. I will calculate v equal to e to the power x square minus y cube minus z to the power 5. Close the bracket. X slice equal to 0.1, y slice equal to 5, and z slice equal to 0. For example, then slice plot, we'll plot a slice x, comma y, comma z, comma v, then x slice, y slice, z slice, like that. So my slice plot, you can see your plot is like this. So this is the slice plot, which is in the form of slices. If you want, you may use color bar in this plot also to show different colors for different things. Okay, so the output looks like this, which is in the form of slices only. These are some commands for plots, 3-dimensional plots. It can have some special commands are also there in the MATLAB, like sphere command. So sphere command is used. Sphere plots. This is a predefined command where you just have to write the command sphere and then the radius of the sphere you have to show. It will automatically show you a sphere. This is showing an sphere. Okay. Similarly, there is command for cylinder. If you want to plot a cylinder, then you have to write, give cylinder have two dimensions. One means it can be horizontal cylinder, it can be vertical cylinder. If you want to plot a vertical cylinder, then you have to use first 1 and second 0. So it will be a vertical cylinder now. Sorry, we have given this command. You have to press enter. As soon as you press enter, you see this. This is a vertical cylinder. And if I want cylinder to be horizontal, then I can say this command can be used. So now the inverted kind of cylinder is got cone. Inverted kind of cone. It's not a cylinder. For making it cylinder, what I have to do, I have to do the third change, that I have to take this and both of this 1. So when I take both of this as 1, then it becomes a cylinder. Otherwise it was a cone. So when it was when I was giving 1 0, then for the first command, when it was 1 0, then this was a cone like this. And I had given 0 1, then cone was like this. And when it is 1 1, then this is actually a cylinder. This is for this, this is for this, and this is for this. These are the commands for 3D plotting. Happy learning. Thanks for watching.